Not working. Cool. Very cool. Okay, so I think we'll get started then. So yeah, like the entirety of this talk, it's going to be like fairly short. There's kind of going to be two options. So like I'm going to breeze through this for purposes of like it being a recording, and it would kind of like take up a bunch of time if we just like screen shared troubleshooting issues in between the slides. So I'm going to kind of go through it, give you like an intuition and context behind like, okay, well, why do we care about this specific component of our development environment? And then I'll hang around for a while until everyone leaves. If you want to set up your development environment, and like if you have any questions, like I can help out, or like if you run into issues with troubleshooting. Also, if like you want to run and you don't want to do this now, this recording and these slides will be available to you. So like maybe during the week you end up like spending some time setting this up, and all it takes is just a ping on Discord. And we can either like hop on a voice channel on Discord or schedule a Zoom so that we can troubleshoot whatever you're running into. So those are two just options for setting this up. So this is kind of an overview of what our development environment is going to consist of. For one, it's going to have Python. We're going to use virtual environments to facilitate our various different environments for our software. And then we're going to use Qiskit as a module that allows us to interact with quantum computers and also simulate them on a classical machine. So like I want to just like take a second to emphasize that this is one of the many ways to set up a quantum computing development environment. There's tons of different languages, tons of different modules that allow you to achieve similar results as to what we're going to do. The reason that I'm showing you this method is because IBM Quantum built like a really amazing textbook to kind of like walk you through how to use their language. And a lot of the intermediate labs, we're just going to be using the content straight from there, and working with that as kind of our supplemental reading for the labs. And so this is like by no means the optimal way. It's by no means like the only way. This is just one of the ways that like you can set up a quantum computing development environment. The first part is Python. And so Python is a very simple language, and it's dynamically typed, it's intuitive, and it's popular. It kind of generally is going to be the language that within data science you'll find most used, at least like with these like newer positions that are coming out. The specific version of Python is going to be the latest stable, which is like accessible through these links. It's Python 3 point, I think 8.7. But these links right here, whether you have like Windows, Macs, or Unix, you would just follow those, and it's going to like, for example, you can click on this, and you're going to want to click on the package for your system, whether it is a 32 or 64-bit. If you don't know, I would go into like your system preferences or like settings, and just look for like system information. And I should tell you, this 32, 64-bit just refers to like the addressability of memory. But that's going, it's going to come with a fairly simple installer for Windows and Mac. And then Unix, it's like, I think you can just get it from the apt sources, or like from most Unix package managers. The next thing, or I guess notes on this. Yeah, so like one, make sure you get the latest stable release. And so if we like looked in here, there's pre-releases, which are like 3.10, for example, which is kind of like an experimental release that will eventually maybe be marked as stable. But like, because we don't necessarily care about, oh, we want the latest version of Python, we would rather actually have the safest version of Python. And so we can get that through the stable releases. And so whether it's like this page or the Mac or the Unix page, you're looking for a stable version. If you're using a graphical installer, so I know it's an issue specifically on Windows that like comes up a lot. I with Unix and Mac, it should just install it on your path for you. And if it doesn't, you're going to need to add it to your path, and we can like work that out together. But I know specifically with the Windows installer, you have to click on a little box that says add to my path. Um, Path, or your path, is just the commands and variables that are accessible to you from the command line, or the command prompt. And so if you want to run a Python program that you just drew up after an intermediate lab, you have to be able to run Python, right? And so like having Python on your path, even though you downloaded it on your system, it might not be accessible to you. It needs to be on your path in order for it to be a process that you can actually execute. So if you are using a graphical installer, if you're not doing this through the command line, just keep an eye out for anything that says add to my path. And you want to make sure that that's checked. So virtual environments. And before this, like we need to talk about just software in general. And so within like creating software and deploying software and having it available for others to use, you're never going to just say, okay, I'm going to create a new programming language and I'm going to release it tomorrow, and there's never going to be any issues with it. I'll never have to update it. I'll never have to fix anything because I wrote it right the first time, and that's that. That is never going to happen. There's actually really interesting proofs that like go as far as to prove that like you cannot write a program to predict whether a given program has a bug. It's also like it's a variation of the halting problem. But like the main point I'm trying to drive at is that like you can't just have perfect software. Software is constantly updated, it's constantly refactored, and it's constantly changed. And so if we think about like a given scenario, let's say that today all of us work together on a project to simulate a 3-particle quantum system. Well, we're going to use Python for it, and we're going to use some quantum computing module, and they're going to be specific versions. So like right here, we're going to have probably used 3.8.7 for Python. And we're going to use some version of Qiskit that will not be the same in the future as with Python, right? And so if we created this project today and we were like, all right, awesome, we got everything working, all the code that we use that is kind of like from outside sources, it just fits in really well and it does what we want it to do. Well, if one of us comes and revisits this maybe 1 or 2 or 3 years later, in that period of 1 or 2 or 3 years, they might have downloaded the next stable release of Python, or they may have downloaded the next stable release of Qiskit. And these new releases might have deprecated or kind of removed some of the functions that we used in our code. And so if I were to look back on this project 3 years later, having installed new versions of all the software, it might just break for no reason other than I am now using newer software than we wrote the program to use in the first place. And so there begins to like to create this idea of like, well, we need to make sure that we can keep everything in one place for a specific project, right? We don't want to have to deal with this issue of like, oh, great, now I have to downgrade all of my software just to look back at a project that I made X years ago. Well, a solution to that instead is the idea of virtual environments. And it's like encapsulating the entirety of your project and its dependencies, the outside code it uses, in a single isolated area of your computer, right? And so if we want to use 3.8.7 in Python today, then we can, and we can also set up a virtual environment specifically for today's project and know that anytime in the future, it doesn't matter how far away it is, we can just use this virtual environment and we can kind of like come back to the past. We can come back to these like versions that we're using today to deploy and use our application, right? And so that's kind of the purpose of virtual environments. Another kind of big idea within computing is the idea of like not reinventing the wheel every time you run into a new wheel. There is like this desire and like this certain novelty that comes with like being able to build like complex and interesting applications. And that can't be done if every little turn we have to completely rewrite a functionality that somebody has actually written something for before. And so like there's this idea of using packages or modules that aren't actually your own code. They aren't actually code that you wrote yourself, but instead they're code that someone else wrote and put onto the internet and said, "Hey, I think this is super useful. If anyone wants to use it, go ahead and use it." And so Python actually manages their index for these or repository for these modules that do various things. Like say you wanted to build an app to have a calculator on a website. Well, you might not want to actually implement addition and multiplication and the various like forms of arithmetic yourself, right? You like that's somebody's done that before. Certainly, there's no need for you to do that. Instead, you can focus on the novel part of your project and just reuse that code from elsewhere. And so pip, the Python package installer, is what we use as a tool to get that software that we want to kind of use instead of reinventing ourselves, right? Pip is going to come with your install. If you follow this link that was in the previous slides, you're going to get pip with your install. And installing new modules is usually just as simple as saying in the command line, pip install new module name. And when I say the word module, I'm referring to this like this calculator functionality, this arithmetic functionality that someone's already written. The word module is kind of an all-encompassing term for outside code that is not directly belonging to this file. And it can be modules that you wrote, or it can be modules that you installed from pip. And the second kind of like or rather the thing that we're going to use to manage our virtual environments is Miniconda. You'll see probably more commonly Anaconda being spoken about. For example, in the Qiskit installation guide, it references Anaconda. Anaconda is just a blown up version of Miniconda with a ton of tools that you probably will never use. So in the interest of your hard drives, I just threw on the Miniconda links up here. Again, like Windows, Mac, Unix, they're like extremely simple. It's just a matter of installing the, at least for like Windows and Mac, it's installing, and I mean, Unix is simple too. But it's installing the installer and then following like these like 5 instructions. Very, very simple. Miniconda is going to allow you to manage these virtual environments that we spoke about, to manage the isolation of like certain packages and versions from others, so that you can come back and look at your code whenever you want and know, oh, I have a virtual environment that already works with this. I don't have to make sure that like my software is the same version as the software that I used when I built this. You know, that's done for you with Miniconda. It has an interesting user interface, if you're one for user interfaces, that kind of like can take care of a lot of the like things that something like pip can. But that's not like the super important part. The important part is just having the ability to set up a virtual environment, which will actually be shown to you in this this next link in the installation of Qiskit. It'll ask you to create a virtual environment for your Qiskit install and your Qiskit projects. And as we start new labs in the future, as we have implementations that we'll be working on, I'll guide you to or advise you and say, hey, here's a good time that would be ideal for setting up a virtual environment, because this project, like we're going to use X and X and X. And so this final part is what's going to allow us. We have this idea of like modules, right? And it's like, okay, outside code that like we don't want to write ourselves. Well, like, I don't know about you, but I wouldn't want to write an entire framework for simulating a quantum computer. That sounds incredibly difficult. Like, I just want to use it. I just want to play with the thing. I don't want to have to build it myself. And so Qiskit is what's going to enable us to do that playing instead of the building of the framework. Qiskit is the framework. It allows you to, if you follow the like entirety of this install guide, it will actually have you set up an IBM Quantum Experience membership. And this allows you to actually send your code to be executed on their physical quantum devices. And so like this is like, to me, like that's freaking awesome. Um, and like if you don't feel like doing this, that's totally okay. We're gonna try and get a way to like get a QCC account set up to have access to this, and like all of us get access through that. But I mean, if you're interested, like it's a free account and it allows you to send code to a quantum computer. Like I think that's awesome. I would totally encourage everyone to go through and do that because it's really cool. And the purpose of Qiskit is not only like, oh, you can use our quantum computers. It's also like you can use your own quantum computers and you can actually use your own local machine to simulate a quantum computer, which is like is difficult if you don't have a ton of like resources on your machine. But it's still like it's still cool. And if you happen to get access to a supercomputer or something, you could just simulate on that and have some like pretty interesting results come out of it as far as like being able to model what a quantum machine should do. And yeah, something that I like mentioned a little earlier is that there's this accompanying textbook. The IBM Qiskit textbook, I think is what it's called. That's kind of what we're going to be using for the rest of these labs. Just because it's so incredibly like well articulated. And it's, I mean, for me personally, it's been crazy helpful in going from like absolute zero knowledge in quantum computing to like still like just like barely greater than zero knowledge. But it's very, very, very helpful. It was like it was really fun reading. Like the last thing that I want to kind of leave off on for this short presentation is like a reiteration of like that previous slide that says like one of the many ways, right? Because this is like not at all the breadth of the like the possible development environments that you could set up. There's a lot of other really interesting frameworks. For example, like Qiskit works on a gate-based uh, infrastructure, whereas like there are photonic based infrastructures that work like fundamentally very differently than gate based technologies. And that's kind of like a whole different world of quantum. It's not at all the case that we are covering um, through the use of Qiskit kind of the only way, or like even the majority of ways to like interact with quantum systems. There's a lot of really creative ways that and unique ways that like this can be done. This is just something that we're going to use because the IBM Qiskit textbook is awesome. But in future semesters, we do plan to use things like Tequila and Penny Lane and Julia and Q Sharp Sharp and all those other interesting frameworks so that we can kind of expand the breadth of our knowledge. This is just the extent of which we will go for this semester. So yeah, thank you so much. I'm going to stop recording now.